You see, it's difficult for me to stay out of the ivory tower. The way universities in particular are set up, they don't want me to spend much time speaking to riffraff like you. They want me to speak to people who are doing physics
Sure.
and measuring stuff and not writing articles in the ASHRAE journal, but writing articles in the European Journal of Building Physics that you don't even know exists.
Right.
And so that's a different bubble. So we have a bubble in the academic world of people talking to each other about stuff, which isn't connected to the bubble that I call reality of how we build buildings. And the systems that we've created from an academic perspective, which I can say now because I'm a tenured professor, I can retire anytime I like. It's just not fit for purpose.
Hey everyone, this episode of Pushing the Envelope is a really exciting one for me. I got to talk with John Straube. John is a quite well-known building scientist, educator, engineer, and I'll let you read his full bio in the description. But I just wanted to say this was a lot of fun for me. I honestly learned a lot and took a lot of interesting ideas away. Things changed my mind and gave me some new ways to think about some stories I've had for some time, and has really motivated me to think differently about how I go about my work educating and talking through some of the issues that face our industry in terms of quality of construction, pushing forward with innovative technologies, solving some performance issues that maybe have been lingering for quite some time in the industry. And I really just enjoyed the conversation. As I said, I took a lot away from it. I hope you will too. So without further ado, here is John Straube.
A lot of it actually is still old fashioned in front of people, although I guess the new fashion version is these types of podcasts. But yeah, on Monday I was, and most of Tuesday I was in spring training camp we have here in Canada but for 200 home builders, people involved in the housing industry. And that's more often how I'm communicating what we do and for them telling me what doesn't work.
Say more about the spring training camp. I'm not familiar with that. It sounds interesting.
It's a get-together that's modeled a bit on Joe Stiebrick's summer camp, and that people show up, they stay at that location. There's not much around them to distract them. In this case, it's very much single-family home builders with some multifamily, and all the people that go around that, meaning like energy advisors, blower door testing agencies, and stuff like that. And so there's 2 days. This is, I think, the 12th or 13th one. 2 days of presentations and on all manner of things that matter that group of people, but very strongly oriented around building science, airtightness, leaks, how to get efficient HVAC, how to troubleshoot air conditioners that are not working right, stuff like that.
Fascinating. Is that specific or targeted specifically at the Canadian market?
It isn't, but a lot of what we talk about would not be of interest to people in Texas. So it's not about the political boundaries, maybe the geographic boundaries.
Sure.
So I
Climate
think
boundaries,
lots of
maybe.
folks from New York State, there'd be literally nothing to be surprising. It would totally be of interest and value. I don't know that there are always folks. I mean, we have usually a speaker from the United States, and we often have some attendees, but it really tends to be a lot more. The word gets out a lot more in the Canadian home building world. We don't get as many people from Minnesota or New York State or Western Mass, where they would share a lot of the conversations would be very, very similar.
Sure. Sure. Well, that's a good segue. So you have, what did you say, about 200 people or something come to this event, and there are other such events. You mentioned Joe Stiebrick's event in Massachusetts in the summer, a variety of other conferences and the IBEC events and things like that. So there's lots of opportunities for people to get this kind of information. Lots of people have this information, right? There's a lot of people that know a lot about building science and how to make buildings work pretty well. And at least in our practice, in my practice, in our firm, and for the whole time I've been doing this, I still run into a lot of the same kinds of head scratching issues that people seem to find their way into, different problems they create or stumble into. It's always a bit curious to me why we keep finding these same kind of problems when the answers, at least to me, are fairly well known and broadly spread. What do you think about that?
I don't think that they're widely spread. I think, in fact, that while there's lots of conferences and so on talking about some of this stuff, much of it is actually not getting beyond surface depth. And the people that are going to those conferences are, I don't think tip of the iceberg is very fair to iceberg's ability to broach water. The building industry is a very large industry. There's lots of people. And unlike one of its distinct features, it is highly disaggregated. It is not like the aerospace industry or pharmaceuticals or even software, where the top 10 firms have dominant positions and therefore can set trends and communicate within their own organizations. There are shocking numbers of builders that don't know that they should be using sub-sill flashing. That's something I believe is easy to communicate. The benefits are fairly well documented and easy to demonstrate. And yet that's throughout United States. This is still a thing that's not done as a matter of course. Here's another one. One of the things I've often said was sort of the cornerstone of North American building science was the conversation about air barriers versus vapor barriers. How many architecture firms do I go into to do a lunch and learn or equivalent where there's abject confusion about vapor barriers and air barriers, and I would say 90%? I'll find someone in the office who says, "Oh, the vapor barrier here." It's like, "Oh, no, you mean the air barrier?" Yeah, whatever.
Yes.
So that to me says we haven't even got past the grade school level of building science if somebody thinks air barrier and vapor barrier are so equivalent that it's whatever, that we can't even be bothered to identify it individually on a drawing. And then the most important control layer that we've learned to talk about is the water control layer, most important in terms of causing the biggest problems. And how many drawings are produced by high-end firms that the word water barrier doesn't show up.
Right.
And yet, Matt, you're saying to me that this is actually fairly well understood. I think actually it's understood amongst you and me and the weird nerds we hang out with. I'm not so sure it's that widespread among the Masons of New York City or the roofers of Atlanta, Georgia.
Yeah, I guess that does ring pretty true. Why then? So you would characterize this as more of a knowledge issue than a execution issue for the most part, like a lack of know-how.
Absolutely. And the more I think about that question, which I think is a really good question, by the way, all of us in the industry have to be asking that. When I first entered this industry, it was presumed by engineers and architects that most of the problems that were experienced were because of workmanship. And the more I've worked on forensic investigations and failures, the more predominant the proportion of failure I attribute to design. Because yes, you can design something that's unbuildable. Is that a builder problem or a design problem? And secondly, what responsibility do we have to make clear what the intent is? Because when I'm on a job site and not even solving problems, sometimes just doing walkthroughs and so on, I'm not often running into tradespeople who are wanting to screw it up, who want to say, well, I came to work today hoping to do a bad job. Now, sometimes they're not willing to put a lot of effort to do a good job, but actually a large number want to do a good job, but they don't know what they're doing. Because no one ever said that the reason we're putting in sub-sill flashings is that we expect that now or in the near future, either the window or the rough opening will leak because materials fail and crack and open. And so I should be able to pour a cup of coffee on that sub-sill flashing and it should all run to the outside. And instead they see their job as instructed. I need to put this product in this location.
Yes.
And that leaves way too much to the imagination.
That's a really good distinction. And I love putting the function of something on the drawings and explaining why it's there. But that exact distinction is the key, is understanding that it's not just put metal here, but what are you trying to achieve?
And we had hoped, I think, we writ large here, that the industry was going to have full three-dimensional drawings and Revit would show everything. And it's like, first of all, that's not even come close to being true. There's just way too much effort required to practically detail everything in a building. And the way that we've been able to, given the minuscule design fees that we get in the building industry relative to aerospace, offshore engineering, or automotive, the only way it works is if we have the trades understand the normal way to do things when we draw normal things on the drawings. And that fills in the gaps. If they know what the intent is and they know what normal practice is, I don't have to say that that 2x floor joist has 4 spikes in it. It's understood that it will. However, as soon as we do different things, both because we're evolving and asking for higher performance, using different materials, or we're being creative designers, well, then those norms are not there. We need to therefore come up with more detailed drawings and specifications. And the only way we can get the trades and even the material suppliers to be able to help with that success is to know what you're trying to do. When you're just selling materials or products, or you're drawing house wrap on the building or peel and stick. I mean, what the hell? How is it possible that a professional designer can go self-adhered membrane or peel and stick and not indicate whether or not is it a vapor permeable one or not? Is it as an air barrier or as a water barrier or both? I mean, it's just mind-boggling that we expect the trade to know what the design intent is there.
Right.
And is this building science, Matt? It's not really building science, but it is what feeds building science. I mean, all the screw ups that result allow us to do all kinds of uncontrolled experiments about how much water does it take to cause corrosion in a steel stud building.
Okay. So given all that, and let's say that the requisite knowledge is confined to some very small minority of the professionals operating in this space. How do we fix that? If like, let's say, I don't know, 10 times, 100 times, 1,000 times that number of people are responsible for creating drawings and specifications and things like that, how do we get that much larger order of magnitude of people up to, at least, as you said, I think, grade school level of building science and building envelope technology?
Well, first of all, let me just, before answering that question, let me just say that I actually don't think we should be looking for a person to know this stuff, whatever that means, because buildings are built by groups of people. And so what we do need, though, is that the team as a whole needs to have the assembled required information, right? So I don't know all the stuff that I need that's needed to build that successful 3-story building. I bring something, geotech brings something, HVAC brings something, and the trades and contractors absolutely bring something. And so just first step there, right? Like, is that we need to ask the question, how does the team that is involved get enough information? Well, there's a multi-step program in the first step of my 12-step program is that we acknowledge we have a problem. And that, I think, is where we've seen the most growth. There's the most growth in the awareness that I could do something I don't understand that causes a problem. I don't even know what I'm doing that could cause a problem, but you hear enough stories, there are problems. So I think we've made the most progress on the one step of that 12-step program of acknowledging there is a problem. But even that is very early stages, because many of the reasons that we're trying today in the United States to build better air barriers is not driven by the awareness that we have a problem. It's driven by somebody is going with a stick is going to insist that I have an air tightness test. And that's not as effective a tool as it is to say, oh, I see, if I make it more airtight, I get better air quality and less air leakage condensation problems and better energy and lower humidity in the summer. But so first I'm saying, like, I think it would be better if more people made more presentations about how buildings fail. One of the strange things that I learned from Joe Stiebrick was that most people don't know how many buildings fail or how badly it can be. And so he was what I thought was he was the disaster storyteller. And I realized that there weren't very many other people out there. If I go to many of my architecture conferences, essentially every presentation is about how fantastic this new building is, many of them which haven't been built, just to let you know
Exactly.
the mindset. And I'm saying, like, I want to look at it on the other end of the spectrum. Like, how about we can talk about maybe the first day of opening to maybe the first 2 years, if I wanted to be so bold. There's almost no conversation, almost none in the professional community about this. The contractors, the General Contractors Association, which we have in many areas, Ontario one just coming up, they're a bit more open about it. They're a bit more honest about. There are presentations about, risks and pitfalls of offsite construction or challenges with alternate project delivery methods, things like this. So they're willing to talk a little bit more. But I think we need to have more discussion about how badly many buildings work and how badly the construction process works, that you and I need to get involved with even before we built the building. Right. I mean, and the architect may never hear about it, or the owner may never hear about it. It's just like we're dealing with a real problem, wasting resources and money, fixing things, and nobody knows. And so then you show up at the next project. You have no idea how a big part of the role I have in new construction is simply saying, "Oh, don't do that. That'll go terribly wrong. Oh, no, 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 it's fine. It's a great deal." It's like, would you like me to show you my pictures on my laptop? Here, let me show you my pictures. And if you don't have the pictures, or you don't have the address of the building to point to, many people don't believe you.
That's
Right? Like,
100%
so,
right.
the curtain wall rep, Connier says, "Oh, this totally works fine." Or it totally doesn't work, what you're suggesting. But wait, you know that this is your product on this building, which is literally 3 blocks down the road, and it either isn't or isn't working, depending. There's so little communication about what's actually working and what's not working that we can't even get past the first step of my 12-step program.
That's a really good observation. And I think it maybe ties in well with my first question, where I think we're living in different worlds to a large degree. In my bubble and Sean's bubble, we have this impression that what we're saying everyone understands and we're all on the same page and it's reasonable assumptions and X, Y, and Z makes perfect sense and it's just rational is the only way you could possibly think about it. And on the other hand, you have a bunch of folks who at their conferences all they hear about is how wonderful the field is doing and the amazing buildings we're putting together or planning to put together and this all this magic design that we're doing. And so when you're
your
coming at it from
values,
these
Matt, also, I think it's like, I understand the bubble. I mean, I would be very much in a bubble if it wasn't for a weird combination of consequences that constantly pierce it. I mean, I'm an academic. I'm at a university. I should be so far up that ivory tower that I don't even see you, let alone speak to you. But through a number of reasons, I would say my colleagues at RDH, where we have a strong presence on the West Coast, Vancouver and Seattle, all kinds of failed buildings there 15 years ago. They learned a lot of lessons. They're now wondering, they come and travel to New York City or Boston or Atlanta, and they're going, "Oh my God, how could people build this way?" They have no idea. And it's like, well, because you're in a bubble too. We're making decisions, for example, in Seattle, where resources are being wasted because we're being very safe, because we got burned and didn't understand why. All we know is that we did something different and it doesn't hurt anymore. That's not science, right? That's grade school level of industrial advancement. It's better than not knowing it hurt and don't do it. But it's not quite, I understand why that didn't work. And so in this new building with new materials, objectives, etc., I know what to do to avoid that problem. That's what I mean by what I think is building science. Whereas a lot of what is called building science is, well, I know that I have to do these materials in this way and beware of these material and weather properties. But if you were to ask, could I use this over a freezer warehouse? That's when 90% of that group would say, "I don't know." Or worse, they would say, "Oh yeah, yeah," without even thinking about how different that ask is. And that's where and I don't think we need a huge number of people in the building science side who can identify that, but we do need a huge number of the people in the industry to recognize that will matter. That we better ask somebody
right.
that could matter.
That's an interesting point, and it's something that I've become a lot more aware of recently, the degree to which most architects expect of themselves to know these kind of, let's say, building science, building envelope technology, the technical architecture, maybe is a better way to put it. The degree to which they take that upon themselves as almost an obligation, and that it's, maybe almost a sense of shame if they have to admit they don't know it or something like this. And that has become a lot more obvious to me of late, and I found it curious because in my mind I always viewed it as like, oh, we're sort of like the structural or the MEP or the lighting consultant that you hire. It's this depth of niche information that, obviously you as the architect with this broad range of responsibilities and skill sets, are not expected to get to that depth in this narrow niche. So you hire these specialists to help you. Yeah. And I always kind of considered ourselves naturally in that realm of specialists. And I come to find out that most architects don't at all. They think that we're doing what they're doing and why would they need to bother with us? And if they don't know it, they almost feel bad about it and can't bring themselves even to admit it, I think, to a degree.
Yeah, I understand exactly what you're saying. However, I think that let's look a little bit from their perspective. I'm of the mind that I am trying to educate architects in a university to know enough to when to call. What are the principles, and know when you're doing something weird and call somebody. And in the field, I like working in practice. I have a lot of architects who are quite keen, and I'm always so happy that they, how do I say this, give a shit. And so we can get into it a bit. But you're correct that especially on emerging technologies and specialist applications, you're asking too much for someone who's got the responsibility for the whole project. But let's also think about how different what we do is than mechanical or structural. Those are delegated designs. There is a legal process in the contracts by which those specialists take on that design and take on the responsibility. Almost all enclosure projects, we do not hand over the design responsibility to the contractor who's doing it or to Matt Copeland. They are saying that's why they're not willing to delegate the design to you or to me for a couple of reasons. If they did so, they'd have to give a large chunk of their fee. Like, structural engineers don't do this for nothing.
No, of course.
Two, they would lose control of something that in many cases is fundamental to the architecture. It's one of the reasons why I think in the closure side, in the building enclosure side, we have to know so much more about what architects want and need, because what we do has a bigger impact even than structure, which they choose to hide it or not, but we've got a big role to play.
Right.
And so they don't want to give up both the control or the money to delegate design to yet another sub-consultant. They do, as I'm sure you're aware, this does happen for things like curtain wall. And I'll point out to you that curtain wall, they don't hire you as the engineer of the curtain wall. What they do is they hire the firm and make the firm have a delegated designer. And this is one of the reasons why curtain wall is the most expensive enclosure per square foot of any enclosure system, whilst having the lowest performance at every metric we can come up with: fire, sound, earthquake, air, water. Well, maybe not air, water, thermal, solar. It's actually the most expensive per square foot. It's the least performing, and a lot of that money goes to a good delegated design so that at least it works. I don't think that if we were to do what they do with structural engineers, it would be okay. And you're giving 0.9% of construction costs to the civil engineer, structural engineer. All right, well, the enclosures at least is important. Give us 0.9%. And how much fee do they have left? So you can see why they would want to learn some of this just from a business point of view. And while because of its architectural influence, they feel they need to learn more about this because they have to be in control of what that building looks and feels like which is a core responsibility they have.
Okay, so let's say that then maybe the longer term arc, the ideal way to go about this whole process is we bring education more widely to the industry and more people are clear on the why and the importance of these things. And so a lot of things start happening naturally because people just understand better. People have been trying to do that at least for a few decades, few decades anyway. So let's imagine there's at least probably a couple decades more before this gets widely distributed to the degree that it might need to. And in the meantime, if I think everything you just said makes a lot of sense in terms of why architects are not going to suddenly start hiring an enclosure consultant as delegating that significant portion of the design to an enclosure consultant on a consistent basis. Maybe it happens here and there, but I'm probably not going to become the norm like structural engineering delegated design is. If you had a magic wand and, it could make a couple changes right now that would make practical, impactful changes in the way that things are, or let's say in the outcomes that we achieve between now and 2030 or something. What do you think are some things that could make major changes?
So that's actually really difficult. I mean, it just seems that I'm not sure that there is a silver bullet like that. I really do. I think this is more of a silver buckshot. So we need to work on so many fronts. But but that said, I mean, one of the hopeful trends I think is the idea of quantifying performance. So we don't call it green. We say how many BTUs per square foot per year does of energy, or how much carbon does it emit. And I mean, I think there's a danger in that of just trying to boil down something as important and complex as a building into simple numbers. But the other danger of just being able to talk any building is a great building just because I said it was is the one we're living with, and it's worse. So we need to move to more quantified performance and quantified in real life. I don't care what the rendering looks like. I don't care what the energy model says. I care what the building looks like, what it feels like. I care how much energy is actually used. And so I think that, especially with the power of simulation technologies, there's been we've been deluding ourselves a lot, both about what buildings look like and how they work. And so I think there needs to be a retrenchment in reality matters. And I think that's in the building industry, I think it's a great place to start.
Yeah, that makes a
Reality
lot of
matters.
sense. Makes a lot of sense. We are constantly exposed to a whole variety of new shiny technologies or new products or this silver bullet or that silver bullet. Is there anything of late that is genuinely interesting to you that you find actually promising, grounded in first principles ideas, or otherwise gives you some optimism that, some new development or some new technology that has you genuinely excited?
I'm actually always seeing interesting and exciting things. It's just interesting. Like literally, this is not a new phenomenon. There's been new ideas and strategies that continue to roll out, but I don't think we need any of them. So the challenges of proper design, construction, operation, and maintenance are so overwhelming that there is essentially no product or technique that I can conceive of that is going to make a big delta compared to the people side of things: design, construction, operation, and maintenance. So, I've been asked over the years many times, like, if we had really inexpensive insulation, would that be a big game changer? No, absolutely not. Insulation is currently cheaper than dirt, and people still want to know how to use less of it, even though it's one of the only products in the entire building that will save you money. So that's the thing. Oh, what about if we had what about? Well, even when we think really blue sky, and sometimes I get in rooms with people saying blue sky, if you had $1 billion to invest, where would you do it? And you're there with a bunch of people and you're ideating what could those look like. Whatever we come up with, none of it looks like it's going to move the needle on a planetary basis. There's a reason my primary job is in education.
Mm-hmm.
Or as my PhD supervisor called it, the anti-ignorance industry, is that it's like just getting more people aware of what not to do, of what you could do, how you could go about making a better building, better world. Yeah, that's probably going to be the most powerful technology we have. And it's not an app. I'm sorry.
I love that. I think that's a great North Star to keep towards. And on the topic of education, one thing that I've found interesting has been the dearth of talent coming into our specific industry, right? There's tons of new architects every year, tons of new structural engineers every year, but finding young talent in building science, building architectural engineering, maybe this sort of middle ground space is very difficult in large part, I think, because most universities don't have a program in anything like what we do. Do you have any thoughts on, how do we grow more of us? Like, how do we get there to be more people like us that can carry this forward and help perpetuate this education and these?
So again, I want to say two things to that. One, it is so much better than it was 20 years ago. It is so much better. And campaigning on this particular topic for me began in the mid 1990s before, in fact, one of the results of that campaign was that I got a job. But true story here, one of the reasons I got a job when my supervisor, Eric Burnett, went to Penn State to build up building science at Penn State was there was not going to be any replacement of a building science person. That wasn't even a thing. And it just happened to be at the time that Vancouver was beginning to experience its condo collapse and crisis. And one of the top consulting firm companies out there's president knew the president of my university and said, well, what are you going to do now that Eric's leaving? And it's like, I don't know. What do you mean? Who's Eric? And where's he leaving to? And it's like, oh, you got the best building scientist around, and now he's going to the United States, and we got a disaster here. What are you going to do? And that actually, well, maybe we should have a building science person. That's how far it was that there were like really 3 or 4 people who did real building science in 1999. And now we're much further ahead. Now, that doesn't mean that it meets perhaps what you're looking for, Matt, in terms of numbers, because the demand is pretty impressive. I would say that we started planning the current architectural engineering program in 2000. In our first class, we welcomed them in the door in, I guess, 2016 or 17 or something like that. So that was when they're the first year course. So they've only been graduating for a few years. And already it's making a difference in markets, not because they can hire them, but because those engineering firms and construction firms who are hiring them are realizing there's a building science. Let's go back to the beginning of your question is that, well, people know this. No, they do not.
Yep.
If you're dealing with your typical who's building multifamily buildings in suburban Dallas, they don't know. And so this is part of the process. We are now at the point where there are hundreds of, more like thousands of graduates a year who at least know what building science is. Now, they're not at the level you want to hire them at because there's only hundreds that know building science enough that you can start teaching them the ways in practice. But that's so much better than it was, okay? So I guess I want to say that I 100% I get what you're saying, but I really do see progress. And here's what I see as the biggest obstacle. There are now many trade colleges, Ivy League universities, and everything in between who now see there is a market for green buildings, energy savings, buildings that don't rot, buildings that don't smell bad, buildings that don't make you puke. All of these add-on features are now being sought by consumers. And they know that they're not teaching that. However, where are they going to get faculty to start a program? Now, this is a problem. I literally spoke at an ASTM conference in 2005 outlining with support from the U.S. Department of Energy, what we kind of needed to do and what were the resources required. And in 2005, it was clear to me the problem was we don't have people who can teach. Not that they're not good teachers, but they don't have the experience. You see, it's difficult for me to stay out of the ivory tower. The way universities in particular are set up, they don't want me to spend much time speaking to riffraff like you. They want me to speak to people who are doing physics
Sure.
and measuring stuff and not writing articles in the ASHRAE journal, but writing articles in the European Journal of Building Physics that you don't even know exists.
Right.
And so that's a different bubble. So we have a bubble in the academic world of people talking to each other about stuff which isn't connected to the bubble that I call reality of how we build buildings. And the systems that we've created from an academic perspective, which I can say now because I'm a tenured professor, I can retire anytime I like. It's like it's just not fit for purpose. And that is actually, I think industry is an easier problem to solve because they're willing to do what makes their life better or more profitable. But there's a lot of these upper educations, they don't even know. And when they find out, they're saying, like we have good trade colleges who say, oh, we need to have more building science. We need more green trades. We need to train them up to be green. Okay, well, who's going to train them to be green? That's not what university or college administrators think about. People are simply, you just plug them in, right? It's like you buy a bearing of this size and you put it in. So, and then the assumption is that that person will be able to teach about the importance of lapping water control layers, sealing air control layers, making sure vapor control layers are appropriately distributed with insulation in the wall system, building sciencey stuff, but we're not training that. So we don't have the people
Yep.
to train the students who want
Right.
to
Right.
and are able to learn this stuff. That's that's the negative side of the story. The positive side is that we're making progress and that there are lots of organizations who want to help and want to make better graduates who can actually be helpful in solving the many real challenges out there.
I really appreciate that perspective. I think that little bit longer time horizon perspective is interesting to me and helps me get a better grasp of where we are and what this cycle probably is. I think I imagined we may have been further along in the cycle than we are in reality, and it may just be a matter of time to some degree.
Yeah, and also, I mean, yeah, it helps to be old. There got to be some benefits,
I'm
and
getting
I've
funny gray
often
hair myself. I
recognized
don't
that.
know.
But I've often recognized that even earlier on, and spoke to my elders, who are now in their 70s to 90s, and people in Canada, and this is where Canada was distinct at the time from America. There were engineers and architects traveling around the countryside, providing education to contractors and designers about flashing, air tightness, thermal bridging, condensation in the 1960s, and fairly well documented seminars in the 70s, which I knew. I only knew them by speaking to my elders, and they're the ones who, in the 1990s, were telling me, "Is like, you have no idea how much better it is now. So many more people actually know. They actually show up at your seminars. For us, we basically had to give away beer, um, and so on. And so I think that it's the maybe the big concern, Matt, should be, okay, we're in a cycle. We're making positive progress, but the rate may be so insufficient for the needs
Right.
that might be the crisis we need to talk about. Can we get the people and the awareness soon enough to deal with what is far from a trivial problem?
Makes a lot of sense. All right. Well, I want to be mindful of time and start to wrap this up, kind of land the plane here. Is there anything that we didn't talk about that you would like to talk about? Any
Oh my God,
particular
you don't have
topics?
2 years, do you? I mean, like, come on. Uh,
Top issue we missed.
no, I mean, I think in terms of top issues, I would break it out in whether I'm talking about the big picture, where I think education and outreach is that key thing,
Yep.
is that we need to increase awareness, and awareness will drive the students and the people to train up. It'll eventually lead to a solution. So we just need to get broader awareness and not tolerate buildings that are just not very good or not nearly as good as they could be, that get put together too slowly with too many problems. That doesn't have to be the case. I mean, that's the promise. And that will empower so many resources and so much opening of door that I think the other problems all come out of it. And I really believe so many people don't know what we could do. We could be so much better. That's on the technology side. I really don't know that, like I said, that there's any magic widget, but I do see cycles of what's coming through the door. And we're seeing, as I'm sure you are, lots of offsite, various types of prefabrication. Although be aware that is totally just cyclical, and that we've been through waves of this with a very strong secular trend from at least the 1920s going, increasing the amount of prefabricated components from our buildings. This is not new. This is not surprising. This is part of a constant trend, but it's now on the upcycle on the news side. But the constant trend is there. And what people forget is that every time we make changes, we risk failure because we can't rely on that experience. And so, not that we shouldn't be making those changes. It's just that when you make the changes, be aware more effort's needed. When you're using 2x10s, you don't have to tell them how many nails to put in the end. When you're using panelized steel stud, you do. And so that's sort of the technology practice side of things I'm thinking about these days.
Well, this has been fun. I really enjoyed it. I hope you did too.
Yeah.
Really appreciate you taking the time to chat with us. Really do.
All right. Good stuff. I'm sure we'll talk again, Matt.
I hope so. Thank you. I'd love to do part 2 sometime.